So we'll start with the introduction part, cloud and DevOps. Okay. So we are learning two things here, cloud and DevOps. Both are different, are looks different, but both are interconnected. Okay, very deeply. Without cloud, DevOps will not work. Or DevOps is not profitable. Or DevOps is not what I can say. Without cloud, a DevOps is a partial part. Okay, so what you mean by DevOps, what you mean by cloud, we'll understand today clearly. Then we'll start with the cloud. Okay, so let me pick the word DevOps. Okay, so what you mean by DevOps? See, when I use this word DevOps, it's a combination of two words actually. Okay, so dev means a developer or a development part here. Okay, and ops means operation part. Okay, so development part means a develop. Suppose we'll start with an example. Okay, it will easy to understand. The development means what you mean by development. So here there is a client. Okay, I will take an example of, there is a client ICICI. Okay, so what do you mean by client? So client is a team or a person or a company who will give a project. Okay, you can understand like this. So ICICI is the client, and the software or IT company is a TCS. Okay, now ICICI bank requires a application. I can say the mobile application, right? So mobile application they required. So what they will do, they will contact not only the TCS, there will be a many Infosys are there. Okay, many things are there, many companies are there. So they will contact or circulate the things. Okay, so they will contact the TCS Infosys for their requirement, or TCS will contact the ICICI for any new requirement or a project. Okay, so that let's consider the only one company, that is TCS. We'll go with this. Okay, so TCS got the project. Okay, so what is the project? To develop the application. So mobile application. So what they will do? Okay, so they need to, here you need to understand the software development life cycle. What they will do, to understand that you need to understand software development life cycle. So development means, see, development is nothing but writing the code or taking the requirement, creating the design. Okay, architecture diagram, then writing the code according to that, and building it and deploying to the server or a production. Okay, so this is all includes the development. So operation is using that application. So once the application is ready, we host it in a server, right? So see, once this application, not, I will not take a mobile application, so it's a, I say it's a bank application because it is easy to show me here. Okay, so once the mobile application, sorry, the application is ready, so it will looks like this. Okay, so I will go to the server or a URL. Okay, so the hosted application I can use like this. Okay, so there is a login microservice, there are many options are there, right? So this is how the login page will come. So this is after the ready, this is the production deployment. So before that many steps are there that we need to understand. Okay, so for that let's start with the, let me complete this word. So DevOps is a combination of development and operation, right? Development means developing the code and building the code, right, and deploying it. And operation means using that code. So here the customer will be using the application, right? So this is the operation part. So this is the DevOps. Okay, so let's understand why we need a DevOps then. Okay, so before DevOps, what was the approach, right? And after DevOps, what is the approach, right? So for that, let's go to the slides. So here, if you see this slide, here the DevOps is a combination of two words, that is development and operation. And here each stages I have shown here. Okay, so development start with the planning. Okay, always there are many things are there before planning. See, the requirement collection, and the business team will go and collect the requirement. They will, according to that, they will do the several meetings, right? Then after that meet plan, the plan will come. So after plan, design will come. After design, the developer will write the coding, right? So the plan, after that developer will write the code according to that plan. That code devops will build. Devops means the server. See, earlier the devops engineer was not there. Okay, so we used to call them as a build engineer. Okay, so earlier, before the DevOps concept, there was a build engineer, because earlier also we used to write the code and we used to build that code, right? So that time build engineers are there who will manage the servers, and they will build your code, compile your code, right? So what do you mean by compiling and all? Future classes will understand clearly. No worries. Just understand the flow now. Okay. So after the build, we need to deploy that to the test servers. Right. So before going to the production, we need to test it internally. So what kind of code the developer has written, right? Is it according to the requirement or not? Right. We need to test it. Okay, it is according to the requirement, but is it working as per the design or not? Right. So that we need to test before going to the market. So that is the testing part here. So after the testing is approved, then it will release it to the market or a production server. Okay. Then once it is released, then it is available to the customer. See here, the customer is using my application or operating the application. Right. So once he is operating, then we need to monitor that. Okay. Then we need to understand what is monitoring also. Okay, so see, as he is using the application, then in between there may be some issues or bugs in the application, right? That you will come to know through the monitoring. Or the customer is facing the issue, then customer care centers are there. So their customer will give the complaint, raise the complaint. Then our customer team will connect or create the report in. Pager duty are there, the issues are reported, so that again come to the development. Okay, see, so from here it will come to the development team. Okay, so again that issue we need to resolve. So that's the reason this cycle is infinity. Okay, this is going on. We need to develop the code, we need to build it, we need to test it, we need to release to the market, we need to, customer will operate it. Any issues are there? Okay, there is no any issue, but still the ICICI bank need a improvement, right? They will come with the new features, right? At least that the developer need to develop again. Okay, every day the new features are coming in a bank application, right? You don't need to go to the bank right now. So everything is online, everything is digital. So they are developing every day, and every week there will be a new option. So this is what the approach. Okay, so DevOps will help you to achieve this. Okay, so this is the overall picture. Okay, it's not a end here, it's a overall picture. So we'll divide it again. Okay, we'll understand the development process. Okay, so for that we need to understand, first of all we need to understand why we need the DevOps approach first of all. Okay, so why we need a DevOps? See, earlier there were many issues. Okay, so the DevOps resolved them. Okay, out of that, I highlighted few of them. Okay, so faster delivery. Okay, so earlier the years and years are taken to deliver or to create or complete an application and hand over to the client. But nowadays, in a 6 month they will complete it and they will hand over at least a part, not complete, at least a part of the application. So how it is, I will explain you. So here we achieved the faster delivery, right, using the DevOps. Then higher quality. Okay, so how we improve the quality, that also I will explain here. Then lesser spending, we reduced the cost here. Okay, with the help of cloud concept we reduced the cost, and reduce the outage. Okay, you still you are you might see in some server is not available, definitely in government applications, right? Some pages are not working in a week, 4 days they are not working, right? Because the infra is not stable right there. Okay, so they are coming now, they will come to the cloud, they will definitely again that applications also work fine, but it may take some time, again the fund required, right? So let it be reduced outage means my application need to work 24 by 7, there should not be a downtime. Okay, if I use my application, my mobile ibanking or my ICICI bank net banking application on Sunday also, at any night, at any time, it will work, your money will transfer, right? So that is what a reduced the outage, there is no any downtime. So these all things are achieved using the DevOps. Okay, DevOps approach, not only by hiring the DevOps team, with the DevOps approach. Okay, then how the DevOps team or a DevOps will work to achieve this, that we need to learn. Got it? So let's move to the next slide. Okay, so here we'll learn how the software is developed first of all. Then we will build it and then we will deploy it. Okay, at least a basic understanding about software development lifecycle methodology. Because if you understand this process, then you can easily compare between the last process or previous our old approach of developing the application and the new DevOps approach. Okay, so very simple. Okay, software development life cycle means, see how, that's the reason I taken an example here. Okay, so how we start building the application, there should be a requirement, right? So the requirement is for ICICI bank, right? So ICICI bank required a application, online application. Okay, so my board is lagging here. Okay, so here ICICI bank required an application, this is the requirement, they will approach to the a company or a software company, that is TCS, right? So they give the requirement, so this is the requirement collection first stage, right? So here requirement analysis or requirement collection, because see everything is sorted before the requirement collection, there are many stages. Okay, that I'm not taking here. Okay, because my business team will approach them, then the cost and all that will be finalized, right? The approximate cost and duration and all, right? So after that they will give the requirements. Okay, so now requirement collection is done. Okay, requirement analysis is done, right? So bank hand out some requirements, so how my application need to be looks like, and what are the features I need, right? So the how the UI looks like, everything they will give, right? So then TCS team will sit and start designing or planning, right? Requirement collection, and after that planning. Okay, then TCS team will sit and plan. So a plan or a design. Okay, so what they will do, they will see, they will understand the requirement, they will understand the resource with them, right? They required a developers, they required testers, they required a DevOps engineer, they required an infrastructure, right? So they will sit and plan. Okay, so who is the where is the platform, okay, on which platform we need to deploy our application. Okay, front end and back end code. Okay, so which technology we need to use here, which is the best technology, right? After a 10 years also it should be a stable in a market, right? So that all things they will plan and do a design, right? After the planning and designing. Okay, so I will write it, sorry. Okay, why it is lagging? So after planning and designing, they will move to the next stage. Okay, that is a implementation. Okay, the plan we need to implement. Okay, so here they will create a diagram. Okay, the flow, how we need to start, right? So the flow diagram, flow chart, or architecture diagram. We call it as a architecture diagram. The architects are there, they will sit and they will plan and they will give the architecture diagram. So parallelly the other resource management team will create a team. They will start hiring the members like developers, right? We require developers, we require a devops engineer or a build engineer, right? We require a test engineer, right? So they will hire. So other than that, many things are there. See, project manager is required, right? So other than scrum manager is required, so many peoples are there. So they will build a team. So once the team is built, then they will start implementing. Okay, they will start implementing the things. So what do you mean by implementing? They will start writing the code, right? See here, implementing part. So developer will write the code, right? DevOps team will start creating the servers or infrastructure in the sense, here to write the code, some we required some servers to store them, right? Then to build them, we still some servers are required. To deploy them, servers are required, right? So to create the document and all, some other complaints and all, the Jira, that boards are required. That everything, the DevOps team, including the project manager and Scrum manager, they will start working on that. So testing team will be working on their test script, right? So if this is the application, then what and all we need to test, right? They will start writing their test script. Okay, so after that implementing, then testing is there. So here implementing means, so developed, we developed the code, and the DevOps engineer or build engineer builded it and they deployed to the test servers. Okay, so after that, then test engineer will come and they will test it. Okay, so after testing there is a evaluation, or a, you need to, what you need to do, you need to discuss with the client. Okay, so testing is passed here, right? So before going to the production, there is a board. Okay, change advisory board, cab team we call it. Okay, so this team will sit and evaluate. Okay, so everything is fine. What is the good time to go for a production, right? Production means a live, your application will come live, customers will start using that. Okay, so that is a evaluation they have given here. Okay, so these words may change, okay, this diagram may change, but you need to understand the approach. So first we need to collect the requirement, then analyze the requirement, then design accordingly, and then implement that design, right? So once that development and is complete, then test that application. Once the testing is done, then evaluate, then move to the production. Got it? So what is software development life cycle? So how my software is developed, that you are understanding in a small diagram here. Is it clear? If you have any confusion, let me know. So here, if you don't have confusion, let's move. This is the approach, this is the process, but now we'll divide this in two part. Okay, in two part I will divide it. So one first part is a before DevOps and after DevOps. See, this is not a correct there are no any kind of types. Okay, before DevOps and after DevOps, this just for your understanding. Okay, so before DevOps we used to follow the life cycle, we call it as a waterfall. Okay, so waterfall process. Okay, and after DevOps is a agile process. Okay, this is the actual name. Okay, because DevOps is a agile process, is it work on a agile method only. Okay, that's the reason after DevOps is a agile, I called it. So before DevOps is a waterfall, it's a old method. Got it? So here in a next slide I shown you waterfall process and a agile process. Okay, the if you feel that words are very heavy, no need to remember right now at least, because as for you guys it needs some time. Okay, so but no worries, right now just understand it. Okay, so waterfall process and agile process. So we'll understand the old method, that is a waterfall process. So here what he is doing, see, he is pulling the whole application. Okay, so what you mean by whole application and what you mean by part of application, that we will understand. Let's move. See here, I'm developing a ICICI Bank application, right? But this ICICI Bank application means there are many features, right? So here I have a login page, right? Then I have a logout page. I have a payment page. Okay, what is the issue? Okay, payment page. Then cards related some options are there. Okay, and okay, I will go with the five things. Okay, or a profile, customer profile, very important. Okay, customer profile. So these are the option in a ICICI Bank application as of now. As of now, it's a starting. They given these, see, whatever the application we start with the minimum features only. Okay, so once it clicked, once it everything is fine, then we will go on adding the other features. Okay, so now in a waterfall method, they used to start once the requirement analysis is done, once the design is finalized, then they will start writing the code for each features. Okay, they will they will take each feature. Okay, the developer will start working on each feature. One developer will write the login code. Okay, or a few two three developer will sit. Okay, and they will discuss and they will start writing the code. Okay, for each of them. So if you writing the code for each feature, then it may take you a more than 6 months writing a code itself, right? Because there are thousands of line for uh, each feature. Okay, if the login page need to work, okay, because here in a login you have a front end, that is a UI part, and back end is a database part, right? So both the code you need to write, both you need to integrate properly, right? So see, the logout is also the same thing. Payment, again there are multiple database related things, right? Validation, token related things, cards related, many things are there. So definitely it may take you more than a year, I can say, because they started writing each code, nothing else. See here, the developer started writing for each line of the code. So let's imagine after a 6 month the code completed, right? So what is the next process? Once the code is ready, we need to build it. Build means, see, this code is nothing but the program they are writing. So that is a human readable language, right? So machine will not understand that. So first of all we need to compile it, then adding some dependencies and library, we need to create one executable file, that is called the build. Okay, executable file. Okay, so this is the build we got. Okay, okay, we got the build here. So the build name is I will call this as a ICICI dot var. Okay, it's a var file. What is var, you will understand in a future class. Okay, so this build we need to deploy to the a test server. Okay, and one more thing, building is not also very easy, because there are thousands of line here. While building, there are many errors will come, because first time you are building, right? There are many dependency related errors will come, that again developers will go on add in each features, right? Sometime your build server get fail because of the load, because you are building a huge amount of code, right? So by many trial and error, you achieved your build is ready. Okay, so that build you will deploy to the test server. This is your test server. So here, what the test server, what the test engineer will do, they will test the application. So up to the test server, it took 8 months of time. 8 months of time. Definitely, it will take, because it is not that easy to write the code for these many features. And after writing, we need to build that, right? While building, there are many errors will come, right? So that errors we need to parallelly solve and again build it, so that we'll get the build deployable file. So that file finally we deployed. So now testers will, after deployment, you will come to know how your application looks like, right? Because once you deploy to the server using that URL, you will log into the browser, okay, and here you will come to know how your application looks like. So this is how my application. Initially, it will not look like this, but just understand, my application looks like this. Okay, so first of all, client is very curious to see the application, right? So he will come, how my application looks like, and he is not happy with the color. After 8 months of time, he is not happy with the color, UI color. Okay, this orange color, what you looking? I don't like the orange color. The client said, I need something green or yellow or any other color, but I don't want a orange color. So what we will do? Whose fault it is? Okay, requirement collected is not clearly, or see, requirement at the time of requirement collection, the client itself told that I need a orange color, but he is not a person, he can't imagine, right, how my application looks like. Finally he is not happy, because he is paying for you, he need a product, so that he will be happy, right? So this color is not okay with him. He told you, I'm sorry, maybe I told you to give a UI with the orange, but now I'm not satisfied, change this color. This is the first bug you received, right? This is the first bug. Okay, now, okay, they collected the requirement. This is the first, that color change we need to do. Okay, then tester started testing. Okay, so they try to log in. While login, it is not taking the password properly, it is taking a repeated password, means same password multiple times. That is also a bug, right? It is not asking for a capital letter or a small letter or a special character. It is taking a random easy passwords also, right? These are the bugs. Okay, after login, it is not properly connecting with the database. While creating the customer profile, it is not creating the profile or storing the data properly, because first time we are testing, guys, understand. You can't imagine that, but see, it is very difficult for a first time testing. There are many bugs will come, okay, just understand that. Okay, we received a list of bug here. Okay, then again, what we will do with these bugs? Bug means issue. Okay, this is also a word, remember. So here my, maybe a network issue or server, this web page issue, I don't know, it is shaking. A bug or a issue we received. So that bug or issue, what we will do, we will send it to the respective development team. So what you developed is not working as per expectation. Okay, so again, developer, what they will do, they need to find out the lines where we need to edit first of all, because more than thousands of 10,000s of lines now. So color related code is in a login UI page. There they will edit it. For any other login related, database related, right, everything. So they will go on editing. Maybe it may take again a 1 month, right? So after editing, again we will build it, again we will deploy, right? So anyhow, we completed a year now. So again there is a pressure on a TCS to complete the project. So what they will do, they will hardly fix some of the bug and they will move to the next part, right? So now what you understood with this, there is a delay in delivery with the waterfall method. So why we call this as a waterfall method? See, here the approach is not reversible. Suppose, see, I will discuss that reversible means what. So here how the water falls and it go away, right? So this is how it is. So here the development is completed, then the build is done, and then it goes to the testing team. Then here you will understand the issue, right? So there is a possibility to understand this color related. Okay, so how it is? It is possible in a DevOps. I will discuss that. Okay, so this color related issue you come to know at the end, right? So it is possible in a DevOps or a agile method. So that's the reason we call it as a waterfall. See, here it is, once the waterfall it goes away, right? So there is no chance for a waterfall at least, but here after getting a issue we can come back and we need to edit the code back. So there is a long time. So now I will discuss how these issues, few issues I highlighted here. Okay, so here for all the code only one database is there now. Okay, suppose testing is passed and here we move to the production, right? And in a production, if any kind of issue with the payment, okay, that is also in a waterfall only I'm talking. With the waterfall process, you achieved everything, your testing is passed and quickly you move to the production to meet the deadline. Okay, now application is working in a production. So after a few months there is a issue with the payment, right? So what you will do, first of all, if there is a issue with the payment means, if you are resolving that means whole application will be down, because it is built in a common source code repository. It is in a same repo, it is a single code base. If you are editing any part of the code, then it need to be builded whole code again, right? So it need to be builded whole code again and it need to be sent again for a testing. So that's the reason. So when there is a issue with the production for any of the feature, then whole application will be down. So then again we need to quickly edit that part, we need to build it, we need to send for a testing. Testers will quickly test it whether that bug is resolved or not, right? Then we will deploy to the production. For that maybe a hours or a day, right? For a production will not take a much time to fix it, maybe in a hours, maybe few hours the application will be down. Once it is resolved and deployed, then it will come back, right? So this is also a issue, but these all issues are resolved with the agile approach. So now I hope you clearly understood why I shown this, why I shown this. The single person is pulling the whole application, not a single person, but we are pulling a whole application and it is very heavy. Okay, it is very heavy to pull it. So when it will be easy? So when we divide it. So how to divide the application then? Okay, so how to divide the application, that comes in a agile process. Okay, so let's understand that. So here I told you ICICI Bank required these many features: login, logout, payment, and cards, and profile. Okay, let's go with these many. So dividing a application means we need to discuss with the client which are the features are very important. So we'll work on that and we will deliver it as soon as possible, and we'll take the remaining for the next sprint means we'll discuss. Okay, we'll take it after some time, that is what sprint. Got it? So now the client side, at least to work on a application we need a login, logout, and a profile creation, right? So okay, now the TCS team designed, right? So that design, they this design will be a different, because here we are not going with the single code base, we are going with the part by part. So here we divided our application in a feature wise, okay, in a microservices. So login will be the one microservice, okay. So we'll write a code, we'll create the separate repository for login, we'll write the code for login separately, right? Logout is also required, the client required. So we'll create the separate repository and we'll write the code here separately, right? Then the profile he is required, profile also required for him, okay. So then we'll take the profile also and developer. So here two developers are working, here two developers are working, and here one developer is working. So he is good with the UI, the UI related, front end related developer will work here. And when it comes to the profiling and all, the backend database is required to store the profile detail. So backend developers will work on this. So there are many things are there, okay, you will understand. So how we go on learning the DevOps approach, many things we will learn, okay. So here we separate the developers and we'll start divided the work, and we given to them, okay. So they started working on this. So this example will last up to the completion of DevOps. You need to remember this example, okay. In between I will repeat it. So now the login feature is a separately designed, developed, logout is separately developed, profile is separately developed. So what do you think, how much time they may required to write the code for these few features? Maybe a 3 months or 2 months. We'll go with the 2 months or 3 months, okay. Within a 3 months, all the features, say the sprint will be not with the months and months, okay, but I'm taking an example, okay. So here within a 3 months they completed writing the code. So next is a build process. So a small amount of code, maybe thousands of line, not a more than 10,000 earlier, right? Thousands of line, maybe less than 1,000 also, okay. So we need to build it. So this is the build, right? So we'll build it and we'll get the file that is login.war, okay. Now we'll build the logout separately, right? And we will get logout.war file. Same way we'll build the profile related, right? And we'll get the profile.war. So these are the builds now, right? So building is also very easy, because more than a less than a 15 minutes are required, or you can take a 30 minutes to build these many lines if you have a more many dependencies and all. So maximum 30 minutes are required if it is successful build. If it is in between failing in the dependency part, then within a 5 minutes you will get the error. So quickly we'll fix here, because the developer here itself, right? So quickly he will fix, because there is a single developer and he knows, because he's working on a single a login microservice, he don't have an headache of all the other features, only he is working on a only one feature, right? So quickly he will fix, okay, I understood why it is failing, he fixed it. Again we builded, then finally after a many a trial and error, we got the build, got it. So here also, and these builds are not one by one, they are running parallelly, understand it. After a login build, I'm not running a logout, because here developer is separately working, okay. He is working separately. Here servers are a build server or a build pipeline is separate, here build pipeline is separate. So that's the reason I can say not a 3 months, I can say a month. Within a month we can build it, because these all the processes are parallelly going, right? So within a month we are able to build, and after the build we are able to deploy, right, to the test server. So what do you think? Within a month, if we are in a testing, then here client will come and see, and now he is telling that my I'm not happy with the UI. Then what you will do? You will create a bug and you will quickly change it, and on the same time, on the same day, or maybe on the next day, you will give the a new color here, new UI color, right? How much time it will take you? A few lines of code you need to add here, right? So his developer is available there, so client will discuss with the developer directly, or a developer lead. I don't want this color, I just want to change the color and the font size and all, okay? So quickly the UI developer will change it, and he will build it and he will give it, and he will ask, is it fine, right? Now client will approve this. Yeah, I'm happy. See, within a month, here it was a year, right? So here also logout also the same thing, they will deploy in a test server, testing team will test it. If any bugs are there, that list of bugs they will send it here, maybe on the same day or the next day they will resolve the bugs, they will update the code, right? Build it, that build you need to deploy in a test server. This is a repetitive process, repetitive. Here the delivery is also fast and quality is improved, right? Improved or not? Because here you have a more time, you can test it as many as times, unless and until you get the appropriate report or a result, right? So this is what the agile process, we divide it and we work on that, so it is very easy to fix without any headache, right? We separately deploy once the testing, all the testing is passed here, right? So all the testing is passed, then we fix the meeting with the client or a cab team. Then once the cab team gives the a green signal, then we'll move to the production, right? So we actually we call these type of microservices, okay? Because this is not a single service, we divided our service in a small features, that is a microservice. And and these microservice we deploy in a container format, okay? So this microservice is deployed in a production in a container, and this also, and this also. Now my login, a logout, and a profile creation, right? So profile creation, so all microservices are in live or a production, so customers are using that. So as soon as the new application is released, the customer will come, traffic will increase, right? So they will, at least they will get the idea about how much customers are there, how much load will be there, right? While developing the next feature, they will take care about that also, right? So here only the profile is created, customer, we can say it is a marketing time, okay? So we release it to the market, so customers are using it, right? As after a few days, once this is a date, this complete, this process is complete, we'll take the payment part and a card part. So the developer will start working on a payment and a card part also, and they will deploy, right? They will build it and deploy it, maybe another 2 months is required, right? So now all the features are within a 6 month, all the features are live. What do you think? Is it possible or not with this plan? So how we manage it, right? Because we deployed in a separate container, how this communication will happen? So that will happen because developer will write the code, so that inter container communication will happen, okay? In a Docker you will understand that inter container communication will happen. This we deploy in a single cluster. This is a Kubernetes, okay? This is a Kubernetes. We need to learn the Docker because of this, right? Because of this approach, Docker came into picture, and to handle that containers, because this, if these are scattered, then it is very difficult to manage them. It need to be in a single trunk, okay? In a single it should be a these should be a branch of a single trunk, okay, or a single tree. So it is easy to manage it in a Kubernetes is the thing. We need to learn that. So here, okay, in a production, if any bugs received or bugs arises, in a payment only, I will take the same example. In a payment there is a bug. What you think? I need to hold all the application? Is it my all the application will be down? No, only the payment related container is down because it has a separate code base, right? Only here I will update, the respective developer will be called, he will update it again, he will build it, he will give the build here, and that build will give the testing team only test that part, right? Once the testing is done, again we can deploy it, right? So again the payment is up now. So for a time being, payment is on hold because of issue, but other features are not on hold, other options are working fine, right? The best example, the day to day is your UPI payment. So it will take the scanner, right? It will scan, it will give the customer detail, you will fill the amount also, but while sending the amount it will show there is a error, means payment related error, right? Application is working fine. Got it, guys?
Yes, sir.
Sleeping or what? So any doubts? What do you think, which approach is better? Agile process, right? DevOps approach. So we need to learn the DevOps, or we need to understand the agile process. So next things is all on a DevOps only. This is the I just created the a story, okay, or what was the history, so that it will be easy to understand the next things. So next thing is, let's move to the slide. So here the same thing I shown you in a sprint wise. Sprint means the same that the delivery time, okay? So here a sprint one means it's a time, it's a 1 month sprint or a 15 days sprint. So if I take this example, in a first sprint the client required a login, logout and a profile. We told that in a first sprint means in a within a month we will give a login, logout and a profile related microservice, we'll deliver it. So that is a sprint actually. Sprint is nothing but the time period, you will just understand right now at least, okay? So what and all comes in a sprint, we will discuss it further. So here we whole application we planned it in a design part or a planning part. In a first sprint what we need to design or develop, in a second sprint what we need to develop, in a third sprint what I need to develop, that we planned it already. So it goes according to that plan, okay? So this is the waterfall. See here, whole thing you need to build, there is a plan for whole thing, not for a part. It's a very heavy, right? That already the few things I discussed over there, what are the drawbacks. So here you can see sprint 1, this is the time, 25th May is the delivery time maybe, right? So once you deliver this sprint 1, then 25th May or 26th May to June is the second sprint time. So you need to develop these many things. Once you develop this, then you need to give or deliver it within before the 25th, because on a 25th June again the next sprint will start and next new task will come to you, or a new thing you need to develop. So this is how we planned it, guys, okay? So now this is the DevOps approach, right? So here we plan it, right? So developer then write the code, build it, test it, deploy it, operate it, monitor it, then come back. If any issues are there, then again it will come to the planning. We will update the plan. Because of this issue we need to change our plan, right? We need to update our architecture. Then according to that, write the code or change the code, then build it again, then test it again, then deploy to the production. So this is what devops process, and I clearly told you right now with an example how this process or how the software development life cycle works, right? So to achieve this life cycle, what and all tools are required? Okay, so that we need to understand here. See, first of all, we need to learn the cloud. Okay, cloud is mandatory because all the servers are running in a cloud. Then Linux we need to learn, because to operate the server we operate it on a command line. Means we need to run the command for each and every process. There is no any clicks. If you are running a Windows server, then you can click, but maximum 90% projects or 95% projects are on Linux server. Git is a source code management tool. So I'm telling that, I was telling here that the developer will write the code, right? So they will not write it on their own laptop. They will write it on their own laptop, but end of the day they need to store it somewhere. The common storage is required. So that is what the Git. Okay, you can understand right now Git is a server, but Git is a process or a software which will help you to manage your source code smartly. Okay, so that is a Git. Then Chef and Ansible Puppet Chef, these all the three are used for a server management. Okay, what do you mean by server management? Now we need to learn these things, but not all, only the Ansible. Okay, let me keep it common. Necessarily it is Ansible I will keep, and I will otherwise let me remove this. Chef, Ansible, Puppet. Right, so out of that, Ansible is famous right now and it is trending. We need to learn this Ansible. And after that, Jenkins. So Ansible is a this one, that server management. Okay, or a server configuration. Suppose you launched the server, or let me take an example of a laptop. You newly bought a laptop, right? You brought a laptop. Then what you will do? You need to configure it. You need to create the partitions first of all. Then required softwares you will install on that, right? Then you will start working, or then you will use it, right? The same way, if you launch the server in a cloud, you need to do the partition, or you need to give the storage for that. Then you need to install the required softwares for your, because you are hosting an application, some softwares are required for that. That is what the configuration. So that configuration also we can automate. Once the server is launched, then required things need to be installed on that, or partition need to be created, right? So that is possible by using this Ansible. Got it? Next is a Jenkins. Jenkins is very famous tool in a CI/CD or in a DevOps approach. So here, what I'm talking about this one, right? From here, the developer will write the code, then we will build it, then it will be deployed to the testing team or a test server. Then once the test is okay, then we will go to the production. So it is not a manual task today's date. It is all the process is automated. Okay, and this automation is achieved in a Jenkins. Okay, so Jenkins is a CI CD process or a tool. What do you mean by CI CD? See, CI simple stands for continuous integration. What you are doing here, you have written a code, so that you integrating by building that. And CD means deploy, and you are deploying to the server, right? So that is what the CI up to here, and CD. So Jenkins is a CI CD tool, Remember it. So Jenkins we need to learn for automation purpose, for build purpose, for deployment purpose. Okay, then comes the Docker. Here I clearly told you, right? So in agile process we create a separate repository for each microservice, and we build it separately using a separate pipelines in a Jenkins. Okay, this build part is in a Jenkins, guys. Very important. The overall part is in a Jenkins only, but separate servers are there, but building part is in a Jenkins server only. Okay, here itself somewhere I'm installing the Jenkins. See, here I'm installing the Jenkins. Okay, I will show you how it is for just a demo purpose. So once it is builded, then that is deployed in a container in a server, and that containers are a Docker container. Because of these things, how to deploy in a container, for that we need to learn the Docker. And multiple containers we are deploying, right? So to manage that multiple containers, right, we need a Kubernetes. So Kubernetes is a Docker or a container management tool. So Helm charts are required to manage the Kubernetes templates. Okay, so Maven is the build tool actually. I will keep it here in a Jenkins. Okay, Maven is a build tool for a Java related code that I will show you with the example. And these are the monitoring. Once you deploy your code, so here, once you deploy your code in a production, then you need to monitor it, right? So by any chance, if your any of the microservice is utilizing the more CPU, and because of the CPU drainage, that application goes down, you will not come to know. When you will come to know? When the customer raise a complaint that your application is not working, then you will come to know. That is not a good approach, right? We need to build a repo in front of customer, right? So we need to take care before the downtime. So for that we need a monitoring system, right? On a single monitor everything need to be visible. Okay, so let me show you how it is. Prometheus. Okay, so this is how the monitoring looks like. Let me refresh it and see, this is the monitoring tool. Okay, Prometheus and Grafana. So this is the Prometheus server and this is the Grafana server. Okay, and here we have some dashboards. See, if I need to monitor my cluster health, then it looks like this. In a single page everything will come. Okay, if any graph goes up, then they will understand. Okay, it may take some time because many panels are there. So this is the Prometheus server. Here you can see these are the data actually. Okay, this data I'm populating here. Okay, let me log out and sign in again. Okay, this page is not available. Let's see. Oh, right, I think the pods are deleted. Morning the nodes are deleted by mistakenly, so pods may be deleted here. See, I will show you here. Okay, see here, this page, if I refresh, this page also goes up. See, this is how the graph will come. Okay, if I scroll down, so this is how the graphs will looks like. If I see, this is how the dashboards we need to create. Okay, I will teach you how to create this dashboard for monitoring. Okay, so this is what the monitoring part. And for monitoring we need to use the, okay, we need to use the tools like Nagios, Prometheus, Grafana, and Kibana. Okay, so we'll learn the Prometheus, Grafana, and if possible, Kibana dashboards also I will create. Nagios is not required. See, some of the project will use this also, but I'm focusing on a trending one or a market. We need to capture a more than 80% market. So today's market is on Prometheus and Grafana. Both are open source. This is very important in a DevOps, because all whatever we are using here all are open source. Kubernetes open source, Docker open source, Jenkins is open source, Ansible is also open source, Helm chart is also open source. So what do you mean by open source? This CloudWatch also I will keep in a monitoring here. Okay, so I will teach you the CloudWatch also. It's a part of cloud only. Okay, so Prometheus and Grafana, Kibana are open source, means freely available. Okay, so freely available means they kept you freely. You can download it, you can install it, you can work on that. So that's the reason I'm able to teach you right now, right? If it is involve the cost, then no one will teach you it freely. Not freely, I'm not talking like that, but it is very expensive, right? The course becomes very expensive, remember it, right? So now these tools are available open source. If you heard the name open source, means these applications are available freely. Okay, now other than that, what we will learn, we'll learn the Terraform. So Terraform is for infrastructure creation. See, if you learn this cloud, so cloud, there are two approach. One thing is you can create the resource or a server. Resource means in a cloud you need to create the servers, right? That servers you can create manually going to the console by clicking, right? But that same process you can achieve by writing the script also. So that is a Terraform. It's a automation part in a cloud. Okay, that also will learn. So other than that, finally we'll understand the project. Okay, projects. So by including these all tools, once we learn, then we'll create some projects, we'll deploy, we'll understand the flow, this flow or this flow, right? So here I will change, I will write some code, or I will do some small changes in the code. Automatically that code will be pulled in a Jenkins server and compiled and builded. Okay, and it is sent to the testing team. Once the test scripts are passed, then it will deploy to the Kubernetes cluster. Okay, some more in a production we have a Kubernetes cluster. That whole process I will show you with the project, right? I hope it is clear, guys. What is DevOps, why we need to learn the DevOps, what is software development life cycle, okay, what is waterfall, what is agile, what are the issues in a waterfall method, and what are the plus points in agile, okay, why we need to use the agile method, right? Everything is clear, right? Are any doubts? If no doubts, then we will move to the next concept, that is a cloud. Okay, so here we understood, or here the two main things are sorted, that is faster delivery and higher quality, right? While explaining the waterfall and agile method, I focused on a faster delivery and higher quality, right? So lesser spending means how to reduce the cost of project, that is possible using the cloud. Okay, so how it is that we will understand. And reduce the outage. Outage means downtime. My application is not working for a few hours or a few days, so that is a downtime, right? So how to avoid that, that we will understand in a cloud. Okay, that's the reason I divided it. So two things we cleared up in a DevOps approach, and next two things we'll understand in a cloud computing. Okay, so what is cloud computing? Okay, see, what do you mean by cloud first of all? Okay, see, cloud is nothing but the a virtual machine. If you go with the name, cloud means something in a sky, you already seen many times, right? That is a different cloud. But same thing, when we virtualize something in a, virtualize means physical format is there. And when we virtualize, what do you mean by virtualize? First of all, virtual means it's a imaginary. Okay, virtual means imaginary in a internet. Okay, see here, you are able to browse a place, your favorite place, right? But you are not on that space, on that particular place, right? You want to go to the moon, so you are watching some pictures, moon pictures. That means you are not on a moon, right? Right. So it is a imaginary, so you can feel that it is just in front of you, you are there only. So that is what the cloud computing. Cloud help you to use the servers which are running somewhere else. Okay, these are the very common, very easiest way of understanding, guys. Okay, there is a standard definition, I will read it, let's see if you guys can understand. Okay, so cloud computing refers to delivery of computing service over the internet. What they told, cloud computing refers to delivery of computing services over the internet. The same thing I told you, right? In other way, what we can imagine it in front, over the internet means we can access it over the internet. Some, that part is somewhere else, but you can feel it, or you can browse it on the internet, on your laptop, on your mobile. So it looks like it is there only in front of you, right? So it allows the individuals and businesses to access and use a wide range of computing resources, including the servers, storage, databases, networking, software, and other services, without the need for owning and maintaining the physical infrastructure. This is very important. Okay, using the cloud concept, no need to own or maintain the physical infrastructure because it is available on a internet, right? So cloud computing means you are running your servers on internet. Got it? Let's understand it in other examples, with the help of examples. Examples will help you to understand it clearly. Okay. Okay, now regions and all, now I will not come. Okay, let's understand this cloud only first of all. Okay, I will go to the whiteboard. See, cloud computing means, I told you, servers are available in a internet, right? So this is my cloud. So how you can create a server here? So what you require to create the server? You required a storage, you required a server, you required a RAM, you required a CPU, you required networking part, you required many things. To maintain that server, you required a AC. How you can install? Right, that is not possible in a cloud. So just cloud is a way to access it, but these servers are running physically somewhere else. That is very important. Okay, so these servers are running here. Okay, so here I have a server, I have here the server has a storage part, this has a RAM, particular RAM, 16 GB RAM, you can understand. So a small server. Okay, 8 core CPU, it has some networking part, it has security related things, many things it has, whatever required. And this server is installed in a Mumbai. Okay, in a Mumbai region, right? So in a Mumbai, it is installed on a land, means there is a construction. Okay, there is a building. Okay, within a building you can install AC now, right? Because server required a air conditioner. There is a load on a server, it's a electrical part, so it produces the heat. To maintain the stable temperature, we need a AC, right? So if you have a AC, then you need a electricity. So somewhere you have a electricity, that cable will come here, right? So that electricity will come here. Then if you have an infrastructure, then security guard will be there, right, to maintain this, right? Because someone come and hack your server, then everything is gone. So security is required, right? And other than that, if you are maintaining the server, then small laptop is required to monitor it or maintain it, and that technical person is also required here, right? So these many things are required to install a server. Nowadays all are launching their own servers. A YouTuber can also launch his server. He don't know, he launched the server in a background. How it is possible, right? So it happened, or it possible because of the cloud concept. Okay, so the world is moving so fast because of this. Okay, so cloud concept. So here, I will take an example that I'm running a hotel. Okay, so this hotel, as of now, it was running good, but I thought that I will start the online delivery also. Okay, so the customers are coming to the hotel, they are eating and they are going, but because of the busy schedule, some of the customer asked the owner, maybe me only the owner, okay, so asked me to start the delivery, because we can't come every time to the hotel. So if you possible, you can start the online delivery. So I'm thinking to start it. So I started collecting the requirement, so I come to know about the application, right? Zomato like application. So i uh, I deep dived in that. Okay, I collected more information, so I hired the developer also. He explained me the features and all what we can give in a application, right? So now he told, at the final he told, you need a server to host that application. Okay, before cloud, this example is before cloud. I will take it after cloud also. Now, okay, I earn a lot of money in a hotel, so I'm ready to invest a crores of rupees now. Okay, so what, after the discussion, I thought to buy a server for me, right? So I bought a server. This is the server. To install that, I created the I bought the land there. I construction is ready. Okay, building is ready. There I installed the server. I took the electricity, some cables and all, the security and all, AC installed. The technical person is hired, right? Right, everything is designed, and this costed me near to 1 crore. Okay, more than 1 crore nowadays, but this is the example. So 1 crore I invested and I started it, right? So at the starting I hardly get the few delivery, few orders, right? But up it months and months went, but there is no improvement in a delivery, right? There is no any orders, right? There are no any orders. So it is a loss making, because you need to, there are expenses, right? You need to pay the bills, there are security, you need to pay for him, you need to pay for this technical person, right? You need to take care about the maintenance and all, right? So other than that income from the online income, the hotel income is also going there only. So at the end, after the 1 year, he thought to shut down this online business. Now he is planned to sell it. Who will buy this? Yeah, buy. There will TCS. You need to sell it to the so-called companies who are ready to buy it in a 50%. right? So this is a loss. The same thing after the cloud concept, again I tried it. So how? After the cloud concept, I hired the developer, I hired the a DevOps member or the person who is skilled, right? So developer written the code that he builded and hosted on a cloud, because on a cloud I launched the server, or the person who is capable, he launched the server on a cloud, right? And he we developed our application, and we started it, right? Again we are getting some orders, a same thing, we are getting a little bit order there, right? But there is, it is not still clicked, because still people, few of them are ordered it, and a few still used to sit in a hotel and they used to eat there only. Still it is a loss making. Okay, still it is a loss making. Again I plan to delete the server. Very easy, because here you are not buying any kind of server, you launched the server in a internet. So how we launched the server in a internet? Okay, so that we need to understand here. So here when you launch the server in a cloud or internet, you need to pay per hour basis. Okay, so as of today it is a per hour basis. Okay, you can give a try, right? You can give a try. If it is clicked like a Zomato and all, you can survive over there. If it is a loss making, then you can uh, pay the bill for a cloud provider and shut down your business here, right? So how my server came into the internet, that I need to understand. So this is the plus point in a cloud computing, guys. So here there are many expenses, but when I move to the cloud, very less expense, maybe a lakhs of rupees I need to give, right, for a bill, right? And these the developers and DevOps, the technical person, and I can set down. Still I have still I, it's a businessman a mind. Okay, if there is a still loss, but he want to give a try because he has some other plan, right? Now at the end of the day he shut down, okay, his online business, and he paid to the cloud provider, and everything is closed now. But here one thing for me, that earlier the same approach was costlier for me, and in a cloud it is still compared to the earlier one, it is still a very less cost. How it is, I was thinking on that, right? So for that, when I start studying about the cloud, I came to know about this concept. How these servers are taken to the cloud. How these servers are available in a cloud. Okay, so that concept we called a virtualization. Okay, virtualization. Okay, the concept taking this a physical machine to the internet, that is a virtualization. So how we can take it, that let's understand that. Okay, so here just imagine this is my physical server. Okay, so here this has some this the resources like a 16 GB of RAM. Okay, and CPU is 8 core CPU. I'm taking very small server. Okay, taking a small server for example, and some storage is there. Okay, today it is not working. I need to refresh, or I need to delete this whiteboard and need to recreate it. Okay, so I will do it tomorrow. So here I need a storage. I will take this storage of 100 GB. Okay, 100 GB of storage is required. Same networking part is required, little bit networking part is required, databases are required. So everything is there in this server. Okay, this is my physical server. Okay, this is my physical server. So now how I can take it to the internet? So I need to install a software here. Okay, this is a hypervisor. Okay, this software is a hypervisor. This hypervisor will help you to virtualize the physical server to the cloud. Okay, so with using this hypervisor you can virtualize means taking your physical machine to the internet, right? So now using this hypervisor, these resources are available in a cloud. So when you log in somewhere, you are sitting here, when you log into the AWS console, there is an option to launch a server, right? When you click on that, configuration setup will come. Okay, you need to give that configuration. So what is the CPU, what is the RAM, what is the storage? Once you give everything, then launch the server. The server is created in a in front of in your server only. The server is created in your server only. The server is created, but that server is created actually in a physically here. How? If your request is for, so total server size is a 16 core, 8 GB, 8 core of CPU, 16 GB of RAM, right? So I selected 1 GB RAM and 1 core CPU, and storage is 10 GB. Small server is required for me. So this much resource is allocated for you here physically. Okay, so you give the name as a demo server, right? With the demo server for a AWS particular account, a person created a server in a cloud. That resources are physically allocated here for you. One server is created. Okay, so here I will create physically, it is created that you can access in a internet. Got it? Using the hypervisor, it is possible to take your physical machine to the internet. Means it is just showing, it is just visualizing you what and all you can do here, right? In the internet, in your laptop, by sitting you can give the configuration and submit it. So that request will come to the Mumbai, and the hypervisor, with that request, the hypervisor will launch one server with that configuration, right? So this is your server 1. Similarly, for another configuration you required one more server, that again request will come, one more server will be created. Got it? So that you are just using in a internet. That is what the cloud. Nothing is there in a cloud. Everything is physically available. Okay. So but that physically available somewhere, that we made it available or on just on your screen, so that we call it as a cloud concept. Understood, guys? Very important concept. Okay, because from next tomorrow's class I will just go on launching the servers. Okay, I will go on launching the servers, but how these servers are launched in my laptop? Not in my laptop, they are somewhere. Why I am taking the name Mumbai? Why not Belgium? Right? So for that also I have a reason. Okay, if you are clear with this, then we will move to that. Why in a Mumbai only? Okay, so let's go. No, sorry. So why in a Mumbai only? So this is the world map, right? So here we are, right? India. So in India, I think it is maybe in a Mumbai. This dot, it should be in a Mumbai because we have a physical server located in a Mumbai. Okay, so this screenshot is AWS cloud provider. Who? What is the cloud provider? Who is the cloud provider? AWS. But what you mean by cloud provider? Okay, that we will understand now. So here you understood clearly that we had a physical server, right? Then who is the owner of this physical server? Okay, This question will clear your concept about cloud provider. Who is the owner of this physical server? AWS is the owner of physical server. Right? AWS, your shopping center. Right? Amazon Web Service. So AWS is the owner. Let me go back. So what, all over the world they have their own data centers, means they have the physical servers allocated, right? Maybe in a movies you already seen there are big database big data centers, right? Big servers are running. Let me show you one image in Google. See here, these all are the physical servers, guys. Okay, so actually he is the maintainer, right? See, he is in tension now. What happened, right? So he is the person who will maintain the things, right? See here, and these are the physical servers, and you will send your request here and they install the software there. See, I very simple way I told you that there is a software, but in actual scenario there are many things to do that. If that server is available in a cloud, means there are many things running in a background to help you. Okay, but no need to worry about that right now. We need to concentrate when the server is available in the cloud, what we can do with that server. Okay, that is not a part of you as of now. If you are really interested, then you can join the AWS. There you can understand how you need to learn the technology, hypervisor technology. Then you can get the job over there and you can handle these things also, right? So as of now we'll learn the after hypervisor, that is launching the server, right? So here the same databases are servers. I'm taking the name servers, but not only the servers, there are many things. Storages are there, databases are there, networks are there, laptops are there, right? So include everything is in a small or in a in a land, right? Same thing what I explained. So here everything is there with this kind of infrastructure. Servers are there, electricity is provided, right? AC is there, security, definitely security will be there, because this is in a Mumbai, I told you, right? So there is a big servers are there, and the Indian related applications data is stored there. Whoever is using the AWS cloud, their data is stored there. If anyone hack that, or if anyone try to destroy that, right? So there need to be security, right? So that security is required, and then maintainers are there, right? Everything, this is what the infrastructure owned by the AWS, and they will give you on lease. That is what the cloud provider, AWS is the cloud provider. Got it? So similarly, if you go for a Google, then Google has its own database center. They also has a hypervisor, and they also provide the services on a cloud, that is GCP, Google Cloud Platform, right? Similarly, microservice, Alibaba Cloud, IBM, Oracle, many things are there. Some of them are on a private cloud, some of them are a public cloud. What is public and private, we'll understand, we'll learn that. I hope it is clear who is the cloud provider and what is the physical database, and how that physical database is took or taken to the internet. That is a virtualization. We call this process virtualization. Physical to virtual. That is virtualization. Virtual means imaginary. It is available in a cloud, right? So how it is possible? Using the hypervisor software that is installed on a physical server, right? Feeling heavy or what? because it's the first day, and we are learning a lot of the things. It's just an introduction, guys. These things will repeat. Maybe in future classes, these things will repeat. Okay, no worry. Just I'm just creating the base here. Okay. Now let me move to the, where is the slide? Okay, so here we have a data centers, and in Mumbai we have, in India or for Asian countries, in Mumbai we have, okay, Asia specific means for our Asian related countries we have a physical data center located in a Mumbai. Okay, now so here why we need a cloud, some theory I have given. Okay, so here first of all I will give the answer for your question, that lesser spending. Right? I think you got a answer here. How we reduced the cost in a cloud. Got it? Or any doubt? I hope it is clear, because here I cleared you. If a common person want to host his application, then he need to set up these things will cost him a crore of rupees, right? But when everything is available and someone is providing the cloud in a internet, sorry, server in a cloud, and there you just need to pay per hour basis, means definitely you reduce the cost. So using the cloud we can reduce the cost. Okay, so next thing, reduce the outage. So how we can reduce the outage here? So we can reduce it here, because in Mumbai location I have a data center. So what about the other people, or people who is working on in America, right? He also want to launch his application. Will he come to the Mumbai, or will he launch his server in a Mumbai? No, definitely, because you can see these dots are all the physical centers, right? So these are all over the world. Let me open it clearly again. AWS data centers, official site AWS. Pricing, solution, product. Let me give it clearly. AWS regions, we call them as a AWS region on map. This will help you to understand clearly. See here, right? So for India it is showing in a Mumbai, there is a Singapore, there is a Virginia somewhere I launched it today, and in some Tokyo is there, Hong Kong is there, right? So California is there, right? So see, Virginia is here, right? Ohio, right? So they all are scattered like this. These all are the physical data centers, right? So why they have created like all over the world in a particular location? They will choose the location. It should be a safe place. There should not be a flood. There should not be a earthquake, right? There shouldn't be any kind of natural calamities, otherwise there will be a big loss, right? So they will find the location which will help them to uh, create the data center for a long time. Okay, they will see, everything is near to the big countries where IT hub is there, are IT related works are going on. Because see, in Mumbai if I am working on an application, then I will launch my application in a Mumbai database only, or a server only. Because when my customer is accessing my application, that request will go to the server only, right? Because inside a server my application is hosted, right? So it will go to the actual server. So suppose a person in Delhi want to access the Zomato application, it is hosted in a Mumbai, right? So that request will come to the Mumbai only. If that Zomato person selected the server in a London here, then see the distance, how much distance the request need to travel over there. That we call as the delay, right? Latency. Okay, so your response and request time we need to calculate, that is a delay. That much time you need to wait for a single response, for a single page opening. If you are browsing the Facebook and it is taking a 5 minutes to open a page, definitely will not create account there, right? So to reduce that, they created the data centers all over the world, so that to minimize the latencies. Not only the data centers, again in a Mumbai they have a three different availability zones. Why so? Here this is the answer for outage, to reduce the outage. Suppose in a Mumbai I hosted my application, right? My Zomato application I hosted here, my ICICI Bank application I hosted here. By any chance there is a terrorist attack and they destroyed it, your application will not work, right? Because server itself is down, the zone itself is down, or a region itself is down, right? So to avoid that, not only the terrorist attack, maybe some natural calamities like anything, earthquake happened, the server, that all the server collapsed, then, or a power outage, what we'll do? If no power, no server will work, right? To avoid that, they again created the small multiple databases all around the Mumbai region. Suppose one availability zone is down, then at least other two are working. Okay, it looks like this. Do we have availability zones here? Let me draw it in a, see, this is your world map. So somewhere here we are in India, and here it is in Mumbai, right? So in India, I'm sorry, I'm not a good, I don't want to make it, so let it be half portion. Okay, so this is in India, right? In Mumbai, suppose this location down, then all over the India application will not work. So to avoid this downtime or outage, they created the three more r- small availability zones. Okay, so these zones are similar data centers only, but small data centers. And when I host my application, what I will do, I will select in a cloud only, this everything, all the options are there in a cloud. So I will select multiple availability zones, so that my server is running in this availability zone also and this availability zone also, right? Suppose this availability zone is down, at least my servers are working here. My servers are working here means my application is working here, right? So there is no outage. This is how we reduced the outage, zero downtime from the data center side, right? So again, you got the answer for this question also, that is reduced the outage in a cloud, lesser spending, right? All the four questions are problems are solved in a cloud and DevOps, right? So now these we call it as a region. So this is the main region, and this region has a three supporting availability zones, so that we can launch our servers in these availability zones. This is the region. Within the region, I can say there are three availability zones. If any one is down, other two are working, and definitely they are on a different location, not on a same location. If it is on the same location, then all three will go, right? So okay, we'll wind up today here, because I think we at least got a answer or a solution for these four issues, right? So tomorrow again we'll start with a different cloud providers, right? So why we need a cloud? See, let me finish up this slide. Why we need a cloud? So you already know, but let me summarize here. On demand self service. Okay. User can provision and manage the computing resources as needed without the need for human intervention from the service providers, right? I'm using the AWS cloud. That means I'm not taking the help from the AWS. They are just providing me the resources. I'm capable to launch my own server. That is what on demand. Suppose you feel that now I want a server and I want to host my application. Just log into the AWS console and launch a server. Within a 5 minutes you can launch a server. And next 10 minutes if the code is ready you can host it. That that is what the plus point with the cloud. If you don't have a cloud, then physical servers you need to configure first of all, hours and hours. So broad network access. So what do you mean by that? You can access your servers anywhere, from anywhere. Not on, no, you need not to be in a Mumbai, right? They are not accessing through the cables, they are on a internet. So wherever the internet work, there you can access it. So that devices like laptop, smartphone, tablets, right, anywhere you can access it. Then rapid elasticity. What do you mean by that? Cloud resource can be easily scaled up and down to meet the fluctuating demands. What do you mean by fluctuating demands here? So recently in the last month, Flipkart launched the Big Million Day, right? So if you search for the customer traffic over there, it is in crores. Before that, there are customers, but the number is only 1 crore, maybe. When the big billion day is there are 10 crores are there. Then how that single server can handle that 10 crores? Earlier it is handling the 1 crore, and now customers are increasing the same server. If you think that same server will help, no, it will not help, right? So what you need to do? Suppose if the Flipkart has a one server for a 1 crore customer, then on a big billion day there is a 10 crore person. Then before a big billion day you need to, before 2 months you need to launch few more servers like this, and you need to wait for that. But there is a crisis are going and there is no money with the customer, then if you launch at the servers for a 10 crore of number but only 5 crores are logged in, what about the other servers? There is no load, but you need to pay for that server, right? So according to the load, according to the demand, one by one servers will scale. That is possible in a cloud only. Okay, suppose I launched the one server for a 1 crore, and there is a slowly increase in a CPU, means network or a traffic. Then there is a load balancer concept that will launch one more similar server automatically and distribute the load here. Okay, so now again slowly traffic is increasing here also, and these servers are also not capable to handle the 5 crores of customer. Only 2 crores are served here. Then again the load will increase. Once that load increase the peak, then again the auto scaling will launch one more server, same server. Okay, again it will divert the traffic there customer. So again 1 crores are handled here, total 3 crores are handled. If there is again load, one more will be launched, so it will go on launching. It will not, there is not required to launch it freely. Okay, according to the demand we will go on launching, and not we, it is automated in a cloud and divert the traffic there. if the if the big billion day over, right, then what about these servers? There is no load. Definitely when the load comes down, one by one it will delete, and it will come to the original one server. This is what the power of cloud. Right, so rapid elasticity means cloud resources can be easily scaled up or down to meet the fluctuating demands, providing the flexibility and cost effectiveness. If you launch pre 10 servers, that is not a cost effectiveness, right? Anything will happen, right? Maybe customer will come, may not be. Then no need to launch it freely. We need to wait because you are paying per hour basis. If you not use the server per 1 hour, it is not mean that it is free for you. If you delete your server on a 59th minute, it doesn't mean that it is free for you. They will divide this per hour charges in a minute also, and they will take from you. So for every minute, for every second you are paying, right? So you need to use it very efficiently. So that is what I have written. So measured services, what is this measured service? Cloud service are typically built based on a actual usage of resources, enabling pay as you go or subscription based pricing model that I explained you. You need to pay how much you used it. Because of these all reasons, the cloud is booming, guys, right? Everyone is on a cloud. After a cloud concept, the IT sector boomed, right? Because of these options only. Okay, so next some slides are there, so we'll discuss it tomorrow. So I will share you this slide. Okay, just go through, do the revision, you only, that what is there, what you mean by DevOps. Just try to recall today's discussion. What is this SDLC model? What is waterfall process? What is this sprint and these tools, right? Okay, everything I will share with you. Try to recall it. Also I will upload the video and I will give the access. Go through it if required. So tomorrow we'll finish up the remaining slides. Few slides are there, and we'll start with the AWS cloud. Then we'll launch our first server tomorrow. Okay. Any doubts, guys? Great. Then if no doubts, then do the revision. I will share you the slide, go through it. Okay, if any doubt, we have a group ping there. Okay, so I will reply for your doubt. So tomorrow actual lab will do, will create how to create the account, AWS account. So I will share you that slide also, guys. Okay, so that you come with the account only. Okay, so let me share my screen. I will explain that also. One very easy to create the free tier account. Let me open that. So where I have that Jenkins source recording session, cloud class, Docker, AWS, Jenkins, EPC, cloud workshop, AWS account creation steps. Okay, so this PPT I will share with you. Okay, so nothing is there. You need to go to the AWS console. Okay, let me go there. I'm not able to create it because many accounts I created, and I don't have emails now, free emails, and let me go to the AWS console. Okay, you can just AWS console login, just type it. So first option is there, just click on this. Okay, and here see, sign in or my account. Here you can create AWS console account, billing, or AWS management console. Okay, I will go here. I think this is the one. So here you have a sign up option. It is showing the login option, but I need to create an account, right? So the account creation options will come. Okay, directly it logged in. Let me sign out. Okay, let me sign out. Okay, login. So when you try to log in, guys, so there is a option in at the bottom. There is an option to create the account. So see here. Okay, sign in using the root. Okay, let me go to the root page. See here, create a new AWS account. Okay, so this account is free for student and individual for 750 hours, because I told you they are charging on a hourly basis. Okay, so this is the first page. So here give your email, right? Your email address and verification, your account name, and verify it. You will get the verification code on your email. In a next step, you need to verify that giving the code. Now let me come back to the uh, page or a PPT, right? So here I given my email ID Sudhakar Bastwade, right? So here I given the Sudhakar as a name and verify it. So in the next page, it will be verified. It will ask you to create, after the verification it will ask you to create the password. Okay, here give the password whatever you required, and give to the go to the next, continue for the next step. There are 5 steps are there. Okay, in the next slide it will ask you why you need an account. So you select it for a personal, not a business purpose, not free it is. Okay, go for a personal, then give the details. Your in personal details are there, your address and all. Okay, so agree it here and click on a next here. So next page it will ask you the card detail. So this is not for a payment purpose, it is for your validation purpose. Okay, they will debit a nominal amount of 2 rupees. Okay, the card will be a debit card or a credit card, both will be fine. They will just verify, uh, because they are working all over the world and they are using their respective payment model, or bankings are a secure one, because these accounts are maybe created by a terrorist, right? So terrorist can use it for his personal purpose, or not personal purpose, for other reasons, right? So to avoid that, this is kind of verification, right? Give the your name, CVV number, and the same billing address, right? And here pan card if you have, then yes, and give the pan card number. If no, then no, right? So here click on a next. So after the next, this is the sign up. Again, payment verification is done. After the 2 rupees deduction, again they will verify your number also. Okay, phone number. Give the phone number, you will receive the text message. Give that message over there, your number is verified like this. And after that, here some personal, like why you need an account. Again, personal, you select it, and individual, type individual, and go to the next, continue. So here you need to select the basic plan. No need to go for this. In a basic plan everything is available. Okay, select the basic plan, and next slide is your account is ready. Okay, very easy. I will share you this PPT also. So tomorrow come with the account. So tomorrow we'll launch a first server. Okay, so great. Then tomorrow we'll launch the server. Then we'll discuss a little bit more about how to handle the servers and all. Okay, bye then. So tomorrow we'll meet on the same time, 6 o'clock. Okay, bye.
Thank you, sir.
Yeah.
Bye.